So, good morning, students. Welcome to the first lecture of the course Sensors, Transducers, and Data Acquisition. So, first of all, I'll like to tell you the importance of this subject. Why this subject is important, and particularly for a mechatronics graduate. Now, sensors, you might be aware of sensors. You might have seen the sensors. They are now part of they are part of our lives. You can see smart homes, sensors are used, motion sensors, and so on. But you might be using those sensors, but you are not aware about the working principle of those sensors, the specification of those sensors. Like you might have used the Bluetooth module, Bluetooth sensor-based module, and you might have interfaced it with your Arduino board or any microcontroller board. But there are chances that accidents might happen. Accidents in the sense, I would like to tell you that when you connect a Bluetooth module without having the knowledge of its operating principle, without having the knowledge of its specifications, you directly connect it to the Arduino board, it will blow off your Bluetooth module. The reason is that Arduino is giving 5 volts, but Bluetooth specification is that it spins the module, it accepts only 3.3 voltage. So it will blow off your Bluetooth module. So here comes the importance of learning what a sensor is, what are the various specifications of sensor, and then only you should go and perform the experiments. So having said that, I'll start this unit by first of all discussing about the introduction to sensors. What do you mean by sensor? What do you mean by a transducer? Difference between the two. Then we'll talk about actuators. Then we'll look out the classification of sensors, transducers, followed by the specifications. That is very important. The specifications of a sensor and transducer. So let's start. I'll share the screen. Just wait. I hope so the screen is visible to all of you. Okay. So this is the course with the subject code MTT202. Myself, Pulkit Jain, I will be teaching this subject. Course prerequisites. In your second semester and first semester, you have studied the subjects BEEE and Introduction to Automation, as well as Physics. So the basic knowledge of that will be required in this subject. So I will be again revising those concepts if they are used in at a particular stage in the sensors. This is the syllabus. This is showing unit 1. So we'll be dealing with chapter number 1, that is Introduction to Sensor and Transducer, their specification and classification today. These are the recommended books. The textbooks you can refer to Newbert, Instrument Transducers, Doblin Measurement Systems. So here is our first slide. So as you can see in the block diagram below, you can see the two elements, sensing element and transduction element. These two are the fundamental blocks or the individual blocks in the overall block diagram of a transducer. Now, you will ask me the question, first of all, what a sensor is and what is a transducer? So, sensor is a device, is a sensing device which will sense anything. What it will sense? It will sense any mechanical quantity like force, pressure, mechanical displacement, any input quantity. So sensor is a device, if I try to define, it is a device which converts an input quantity, that is a physical quantity, a mechanical quantity, in the form of force, pressure, anything, into a electrical quantity, into an electrical signal. Electrical signal means voltage, current, or in the form of variation in resistances. But generally voltage and current are the parameters. Now, transducer, what is the definition of transducer? Transducer is also a device which converts input physical quantity into output electrical quantity. So definitions are similar. Where is the difference between the two? the output of sensor is not always guaranteed to be electrical in nature. This is the main difference. But in case of a transducer, the output will always be electrical in nature. That's why in the block diagram, as you can see, this is the block diagram of a transducer where the first element is the sensing element. Sensing element means the sensor. So that sensor input is any physical quantity to it. It will convert it into an intermediate form that will not be always electrical in nature. If it is electrical, then sensor and transducer, it is no difference. They both are working in the same manner. But if the output is not in electrical form, like it is in some intermediate form, and you need a transduction element, a medium, a resistive medium, a capacitive medium, or a inductive medium, that will be your transduction element to convert that intermediate signal form into an electrical signal that will form the part of your transducer. So I hope so the difference is clear to you. Now, this diagram basically shows you the functional elements of a transducer. So as I have already told you, first will be the measurand, the quantity to be measured. That will be your physical quantity, mechanical quantity, mechanical displacement, force, pressure, anything. And it will be first fed to a sensor, that is the primary sensing element, whose output will be in analog form, in analog nature. But generally it is found that it is not always in electrical form. So it will convert it into some intermediate form. Like example is shown here in this slide. You have a strain gauge. Strain gauge sensors we will be dealing in detail later words in the chapter. But just for introduction, strain gauge is a resistive element based sensor whose the functionality of that is input is a force, a strain is applied on this device, which brings about a change in the orientation of this device. Orientation in the sense here I means it brings about a change in its dimensions like length, area, which ultimately brings about a change in its resistance. As you know that resistance depends upon R is rho L upon A. It depends upon length, change in area. So if you change the area length by applying the force on the strain gauge, it will bring about a change in resistance. But this change in resistance, how can we measure it? Is it, we want to measure the input quantity, that is force, but there is no parameter, such parameter to be able to measure this change in resistance. So what we'll do? Here comes the second part, that is the variable conversion element. So variable conversion element will try to convert the output from the strain gauge into a form that is electrical in nature. How that will be done? It will be employing certain kind of circuitry. As you can see in this block diagram, on the left hand side, after strain gauge is connected in one of the arms of a Wheatstone bridge circuit. This Wheatstone bridge circuit you have studied in your +2 physics class, where one element is in Wheatstone bridge you have 4 resistive elements. Two are the standard one is the unknown, one is the variable one. So strain gauge, here it is the unknown one whose value you want to calculate. R1 and R3 will be the standard one, R2 one will be there to vary. So by using the concept of this null detection method using the galvanometer, you will be able to convert the change in resistance into an electrical signal, that is a potential difference. So our part is done. Our need was to convert the input force into a electrical signal. So we have got a voltage signal here. But after that, there is one more element, that is variable manipulation element. Because variable conversion element will convert it into electrical form. So that physical information that is there, force, it is there within this. It has not been lost, it has not modified it at all. But in the variable manipulation element, there is a need to convert these signals into a particular range of values. These are the 3 standards which are used in industries. For voltage, it is 0 to 5 volt. It is the standard range. Current range is 4 to 20 milliamps. And if you talk about pressure, PSI stands for pounds per square inch. This is a unit of pressure, pneumatic pressure values. So the standard values is 3 to 15. You might be worrying here or asking a question. There might be a question why it is 4 to 20 milliamps, not 0 to 20 milliamps. So I would like to give it to you as an assignment question. that why the industry standard of current is 4 to 20 milliamps, not starting from 0. So you search it out. I'll just give you a hint here. 0 means no current flow in the circuit. So for fault detection in the circuit, you will not be able to identify if the standard is set to 0 milliamps, because 0 milliamps means maybe the circuit connection is broken somewhere, and that's why it is showing 0. But if the circuit connection is proper and some current is flowing in the loop, like minimum value of current 4 milliamps, then I'm able to do the fault detection much easier. Live test detection is also possible with the help of this standard. So you try to find it out why this is kept 4 to 20 milliamps. Now, after this manipulation element, we have data transmission element. Data need to be transmitted from one location to the other, because generally sensors may be employed in one area, but your measurement may be taking place at some other area. So you need a transmission medium. So transmission medium can be pipes, electrical cables, or radio links, Wi-Fi, wireless. So these can be used. Then after that, you have data presentation elements. So once you are able to measure the data or being able to transfer the data to a particular location, to a remote location, there you need to display the data as well, so that you are able to analyze the data visually. So analyzing the data, it can be in the form of analog meters, normal analog readings like in the diagram you can see. Then in the form of digital readouts, digital meters can be there, or it can be in the form of CRT screens as well. CRT screens is your oscilloscopes. Just like you see the ECG machines, there the waveforms are moving. So just like those, you have CRT screens. Old televisions also used to have these CRT screens within them. Digital readouts are the digital counters. Okay. So I hope so the difference between a sensor and transducer is very much clear to you. Now the third term comes is actuators. There are actuators as well. So what actually is an actuator? So sensor and actuator, they both are separate things. So first of all, let me make you very clear. Sensors generally refer to the input devices, the detector circuits, but actuators are the movers. They are the output devices. So to show the difference between them, or to show a sensor to actuator flow, you can see from the diagram below. Here, first of all, temperature sensor has been used to detect, means if temperature goes very high, if smoke is there, so it is used to detect heat here. So in degree Fahrenheit or in degree Celsius. Then this sends, the control center is there in between, which is used to send this detected signal from the sensor to the control center via wireless medium or cables. The control center will now send the command to the output device. That will be your actuator. It will be consisting of your motors, moving parts that will take the action depending upon the feedback they have received from the sensors. So like control center here will send the command to the sprinkler. Sprinkler will turn on, the motor will turn on the sprinkler, or the valve will open, and it will turn on and it will put out the flame by spreading out the, or pouring out the water. So this is the flow. Next is examples of some sensors and their corresponding actuators. Like example you can see here, first is the quantity being measured. Suppose if I talk about simple, first of all, let us talk about temperature. So temperature is the quantity I want to measure. What all temperature sensors are there? Thermometers are there, thermocouples, thermistors, thermostats are there in air conditioners. They are used to monitor the temperature levels. So they are used to monitor the temperature level. They are acting as a sensors or your transducers. But what they are controlling, what actually hardware device they are controlling with the help of motors or some actuators, that is your heater, fan, air conditioner. So those are output devices referred to actuators. Similarly, if I talk about speed, like speed, when you want to control the speed of a generator, a motor shaft, there you need to have a motor. Okay, you send a signal, you send a voltage signal, you send a current signal, okay, to control the voltage and the RPM. But what device is actually carrying out the motion? They are the motors only. AC motors, DC motors, stepper motors, number of motors are available. And similarly, one more example if I take is of sound. So sound sensors are piezoelectric crystals. I'll discuss this in the next slides as well. The piezoelectric crystals are available. They are the sensors, and output devices can be bell, buzzer, loudspeakers, and so on. Like generally sensors, what are the advantages? They are can be used to raise out an alarm. Like when the temperature goes very high above the limit, above the threshold limit, they may raise out an alarm, buzzer, loudspeaker, anything. So that is the example of sensors and the actuators. Now, next topic I'll cover here is classification of transducers. So there are various categories on the basis of which this classification can be carried out. Like first is on the basis of the transduction principle. So transduction medium, as I have already told you, depending upon the transduction medium that you are using, it can be resistive medium, capacitive sensor, or inductive sensor. You have the transducer classification. Like resistive one, you have potentiometers. Potentiometers, simplest example is your fan regulators, the voltage regulator devices. Inductive proximity sensors are there, capacitive sensors are there, many sensors are there. So these are on the basis of their operating principle, whether you are using a if you are using a resistive transducer, that will be based on resistive transduction, inductive, capacitive one. Now next classification is primary, secondary, active, passive, analog, digital, transducer, and inverse transducer. So I'll talk that in detail afterwards in the next slides. So primary and secondary transducer, this is very important. Primary sensors or transducers, as I've told you in the starting slide, where I've talked about, where I have discussed about the block diagram of a transducer. The primary sensing element is your primary sensor, but the overall diagram which involves primary sensing element, the transduction element, becomes the overall transducer. So with the help of a simple example, you will be able to understand here. So here, two devices are being used. First of all, on the right hand side, this reverse C-shaped tube is there. This is known as a Borden tube. This is the input to a Borden tube is a pressure. As you can see, pressure from the bottom is given, and it is connected to a cord. So input quantity will be a pressure quantity, as you can see in the top as well, to a Borden tube, but the output will be a displacement of the cord to which the free end is connected. So what will happen in this case is this Borden tube is acting as a primary sensor. Or why it is a primary sensor? Because it is converting the input mechanical quantity, that is pressure, into again a non-electrical quantity, that is a mechanical displacement of the cord. But then after this cord has been connected to a core of the LVDT, the soft iron core of a LVDT. This LVDT is linear variable differential transformer. You might have studied this in your BEEE class. So it consists of, you know, that one primary winding connected to a AC source, two secondary windings, and the output voltage is there. Depending upon this core movement, whether it is close to secondary winding number 1, output voltage will be positive. If it is close to secondary winding number 2, output voltage will be negative, or the direction will be opposite. So here, the input quantity to this LVDT is displacement, and the output you are getting in the form of a voltage. So this Borden tube here, it is acting as a primary sensor, and this potentiometer is acting as a secondary transducer, that is converting or giving you output as a final voltage signal. Next, analog and digital transducers. Next classification. So analog transducers, you might be aware of analog signals and digital signals. So the transducers can also be classified based on their output signals, whether it is continuous in nature, it is continuously varying with time, or it is defined only at some discrete points in time. It is digital in nature. It is 0 or 1 form. Now, analog transducers, I'll read out its definition. So it will change the input quantity into a continuous function as an output. Simplest example are your potentiometers, LVDT, strain gauges. So output quantity will be in the form of a analog quantity. As you can see on the bottom left, a pressure transducer is shown to you, where a pressure transmitter is converting the input pressure, air pressure, into an analog electrical signal, where you can see an analog readout here. But if this output analog quantity is being converted somehow using some circuitry into a digital form, like in the form of 0 and 1 pulses. Like a LED is there. It is switch on, switch off, 0 and 1 position. Only two states are there. It is only having discrete states. Only two states, high and low. So here on the bottom right, you can see a diagram of a wheel speed sensor. Like a Hall effect sensor will be used in a wheel speed sensor. We'll discuss in detail the working of this in the later on lectures. So just here, I want to show here this wheel movement. When this wheel is close to this, okay, then it is reading a 0. When this wheel tooth is not there, it is reading a 1. So this 1 and 0 means presence or absence. So this presence or absence in the form of a pulse, if you are able to convert with the help of a transducer, that becomes a digital transducer. Other examples are optical encoders, digital encoders. Many examples are there. Next is transducers and inverse transducers. So transducer, I hope so the functionality is clear to you. It is a device which converts input physical quantity into output electrical quantity. But inverse transducers, they perform the opposite function. So just if you try to relate it with the actuator, what does a motor do? It input, we give it electrical quantity, we give it current, we supply it voltage, and output is the shaft of the motor moves. Output is the displacement. So inverse transducer also fall into the same category. The input is electrical quantity in this case, and the output is in this case is a mechanical displacement or any kind of mechanical quantity. Best example is a piezoelectric crystal. As you can see in the bottom diagram where the animation is shown, a piezoelectric crystal, piezoelectric transducer is a transducer which can behave as a transducer as well as inverse transducer. It has the property to behave as both. The reason is that when you apply pressure on both the ends of a piezoelectric crystal as shown here in the diagram, you get a corresponding voltage difference between the two ends as shown by the voltmeter in this diagram here. But if you carry out the reverse process, that is, if you apply the voltage to the two ends, it will bring about a change in the orientation of the crystal. It will bring about a change in its mechanical, it will carry out a mechanical displacement in it, a change in its dimensions. So it can work as a transducer as well as inverse transducer. Next classification is active and passive transducers. Last classification. Active one are those which don't require a power source to produce any output. They are also known as self-generating type transducers. But the passive transducer, they require an external power supply for them to work. That's why they are known as external power transducers. Simplest example is your solar cell. You don't need any power. You don't need to supply any external power source. A simple solar panel, the light falls upon it, it generates the current. So it is self-generating type. Thermocouples are another type of temperature sensors which fall in this category, the active transducers, which converts this temperature gradient, temperature difference between the two ends into an output potential difference without needing any power supply. Piezoelectric crystal we have just seen. But examples of passive transducers, potentiometers, simplest example, they require a voltage to operate. We have seen LVDT in the previous slides. It requires a AC voltage to be supplied to its primary winding. So it is requiring some voltage to work. Then last point, the energy required for production of output signal in case of active transducer is obtained from the physical quantity itself. As you know, energy can't be created nor be destroyed. It is deriving the energy from the, you can say, the device itself. And passive transducer, on the other hand, require auxiliary power source to produce the output. Okay. Next is sensor and transducer specifications. Very, very important parameters. So you should be aware of these parameters of any sensor you are working on, because this subject will help you a lot when you are designing projects, when you will go for internship, when you are doing training, when you're designing some mini projects, major projects. any project where you want to design a mechatronic system, you require to use sensors, motion sensors, Bluetooth sensors, IR sensors, touch, touch sensors, proximity sensors. So you need to have the knowledge of specifications first. So I'll start with the specification now. First is range. Range of a sensor. Range, as you know, it defines the limits of input. What is the maximum value of input that the device can handle? Like I told you, the Bluetooth module, it requires only 3.3 volt for its operation. It can't handle voltages above 3.3 volts. But if it connected directly with the Arduino or microcontroller, which is giving 5 volt, it will blow off your Bluetooth module. So you need a voltage divider in between that will convert it into that will step down the voltage from 5 volt to 3.3 volt. Similarly, example is a typical thermocouple. Its operating range, because it is a temperature sensor, its operating range is it can work from 25 degrees Celsius to maximum up to 225 degrees Celsius. So this is its operating range. You should be aware of this while working on the thermocouple. You can't go beyond this range. The device will not work. Span. Span is a simple thing. It is a difference between the maximum and the minimum input value that a sensor can withstand. So as for the same example, thermocouple, it will be 225 minus 25, that is 200 degrees Celsius will be its span. Now, next thing is very important, error. Error you might be aware of. One is the actual value and one is the measured value. Actual value means the standard value that should come out of the device or the instrument or the sensor. Like thermocouple is here, you know that it should give you 39 degrees Celsius. Sorry, 29 degrees Celsius as the standard value for the room temperature or a particular temperature of a particular environment. But when you try to measure it with some thermocouple that you have bought or any other temperature sensor, if you get 30 degrees Celsius, so the error is of 1 degree. It can be plus, it can be negative as well. Like you can get 28 degree, so 28 minus 29 will give you minus 1 degree. So it is a simple, it is the difference between measured value and the actual value. Now, next comes is accuracy. Accuracy is very important. Accuracy shows the closeness between the actual value and the measured value. It shows the closeness of my actual value to the measured value. How close my actual value is to the measured value that I have obtained after carrying out the experiment. So what's the difference from error is that it is expressed as percentage of full range or either full span. I'll give you an example. Like it is written over here, a pressure sensor can measure from 0.7 kPa kilopascal to 70 megapascal. So what will be the accuracy then? So if it has a plus minus 1% error, then it will give you accuracy of 1% of the full range. What is the full range in this case? 70 megapixel. So 1% of full range will be plus minus 0.7 megapixel. So this will be the accuracy of your result, plus minus from your actual or standard desired value. Next is sensitivity. Sensitivity is nothing but it is a ratio of output to the input value of the device or the sensor. I'll tell you the difference between sensitivity and gain as well, because gain of a device is also similar. It is also the ratio of output to the input quantity. So what's the difference between gain and sensitivity then? Sensitivity is always the ratio of output to input. Both are the different quantities. But gain is the ratio of output to input. Both are having the same units, same quantities. That's why gain is unitless, but sensitivity is having certain unit. Example for a thermocouple, again I'm taking. A typical thermocouple has a sensitivity of 41 microvolt per degree Celsius. What does it mean? It means that for every 1 degree change of temperature in degrees Celsius, it brings about a corresponding change in the output as 41 microvolt output. Okay, but gain will be output, input, both similar quantities. It will be dimensionless, it will be unitless. So now I would like to summarize this lecture. So basically, we studied about sensors, transducers, differences between them. Then we studied the flow from sensor to actuators, their applications. then followed by the classification of sensors and transducers, and lastly we learned about the specifications. So these are the references that were used for preparing this lecture. So you can refer to the textbooks. Also, you can refer to the NPTEL documents for sensor specifications that I will be sharing with you. Okay. So in the end, I would like to tell you that just go through it, all the content that I have shared with you today. And even some questions I have also given to you in between the slides, like why 4 to 20 milliamps is used for the industry standard. You also try to find out some applications of sensors that you might have used or you might have come across. And if any doubts, you can send your queries to my mail ID, that is pulkit.mac@cumil.com. Thank you very much for patiently listening this lecture. Thank you.